Good morning, students. This is next topic, that is shapes of orbitals. That means we have to discuss about shapes of s orbital, p orbital, d orbital, and f orbital. First case, s orbital. It has spherical shape. That means its shape is like this. Its shape is like this in 3 dimensions. Next, it is a non-directional orbital. Non-directional means in that spherical shape, no direction. That means electrons revolves around this orbital. That is the meaning of that one. In all the directions, in x-axis, y-axis, z-axis. So that is, it has no specific direction. Next, in case of p orbital, it has dumbbell shape. That means this is dumbbell shape. I discussed already. P subshell contains 3 p orbitals. They are px, py, and pz. What is the meaning of px? That means that electrons density present on x-axis. Electron density not present on y and z axis. That is the meaning of px. In case of py, electron density present on y axis. That means electrons present y axis only. It is electrons not present in x and z axis. In case of pz, electron density present on z axis, not in x and y axis. That is the meaning of the point. But it is directional orbital because in the case of this one, electron density present on x direction. Here y direction, here z direction. That is why it is directional orbital. Next, in case of f orbital, not f orbital, d orbital, it has double dumbbell shape. Dumbbell means one lobe. Here 2 lobes. This is one lobe, this is one more lobe. That is why this is called double dumbbell shape. All d orbitals are having double dumbbell shape and it is directional nature. Why we should say like that? Because see here this electron density present between, not along, between x-axis and y-axis, not in z-axis. That is why it is directional. Here also. And here one more point is that these 5d orbitals are again classified into 2 types. These 5d orbitals are again classified into 2 types. They are T2g and EG orbitals. T2g and EG orbitals. D subshell contains 5 orbitals. I told you already. They are dxy, dyz, and dzx. And dx square, y square, dz square. These are 5 d orbitals which are present in d subshell. Now dxy, dyz, dzx, these 3 orbitals comes under T2g orbitals. In these 3 orbitals, electron density is present between the axes. But in these 2 orbitals, electron density is present along the axis. In the EG orbitals, EG means dx square, dy square, dz square. These are called EG orbitals. dxy, dyz, dzx. These 3 are called T2g orbitals. So in the above case, electron density is present between the axis, but in the below case, electron density is present along the axis. Here dx square, y square. That means electron density is present along the axis. In dz square, that is present along z axis. So this is the about shapes of orbitals. Next, orbit. Orbit means what? The electrons which are revolves around the nucleus in circular paths, those circular paths are called orbits. Those are called shells. Those are also called energy levels. We know that about it very well. Next, orbital. Orbital means, here this is somehow important point, the region or space around the nucleus where the probability of finding the electrons is maximum is called orbitals. The region or space around the nucleus where the probability of finding electrons is maximum is called orbital. Suppose, see, this is nucleus, for example, these are orbits, These circular paths are called orbits. First, for example, we will discuss about the second orbit. Suppose electron revolves continuously around this orbital. If suppose if electron present mostly here, mostly here, then that space is called orbital. That space is called orbital. I just repeat it once again. This is nucleus, these are circular paths, these are called orbits. Orbital means what? Where the chance of probability of finding electron is maximum, then that chance is called orbital. If suppose electron exists here more time, suppose, then that place is called orbital. That place is called orbital. So what is the definition? The region or space around the nucleus where the probability of finding electron is maximum is called orbitals. Next, node or nodal region or radial node or nodal space or spherical node, all are same. Node or nodal region or radial node or nodal space or spherical node, all are same. What is the definition? The region or space around the nucleus where the probability of finding electron is 0, that is called node. See, the region or space around the nucleus where the probability of finding electron is 0. If the probability of finding electron is maximum, that is orbital. If the probability of finding electron is 0, that is node. Suppose in the same example, if suppose electron is not present here, that means electron revolves continuously, but in this place, suppose if electron just comes like this and immediately it goes to other place, then automatically this place, in this place, we cannot find a electron. We cannot find probability of finding the electron. That space is called nodal space or node. Electron revolves around the nucleus continuously, but in sometimes that electron is present at particular space more time, and in some particular space, in some particular places, it exists very less time. That is why that place is called node. This place is where the chance if electron is present more time in that particular place, that is called orbital. I tell you one natural example, then you will get one clear idea about it. Suppose take myself, I am the example. When school opens, I usually present from morning 8:30 to 2:30 in school. Before the time, after the time, I usually present in my room. Then that school and this room are orbital, because in those two places I exist. I usually present more time. But this route is there between my room and school. That route is there. I am going and coming through that route. But if I cannot, others cannot find me in that route, because I just move and coming through that route, so that others cannot find me in that route. So that route is considered as node. I hope you understand this example clearly. Otherwise, we will discuss this part in live class. So what is orbital? Orbital means the electrons revolves. The region or space around the nucleus where the probability of finding electron is maximum is called orbital. If that probability of finding electron is 0, that is called node or nodal region. Here, then the formula to calculate number of nodes. The formula to calculate number of nodes is n minus l minus 1. The formula to calculate number of nodes is n minus l minus 1. Here number of nodes for 1s orbital is equal to n minus l minus 1, where n is principal quantum number, L is azimuthal quantum number. See, this 1 indicates principal quantum number, so that here n value is 1. As for s orbitals, L value is how much? 0. So 1 minus. So what is the formula? 1 minus 0 minus 1, so 0. So that means in case of 1s orbital there is no node. There is no node. In case of 2s orbital, number of nodes for 2s orbital, what is the formula? n minus 1. 2, that means 2 minus 0 minus 1, that means 1. That means in case of 2s orbital, one node is present. In case of 3p orbital, the number of nodes are 3 minus 3p, 3 minus 1 minus 1. So finally 1, because for p orbital L value is 1. See, this first number indicates n value. This number indicates n value. So 3 minus 1 minus 1, finally 1. In case of 3d orbital, number of nodes are how much? 3 minus 2 minus 1, finally 0. So these are what number of nodes. This is the formula to calculate number of nodes. This is very important formula for 1 mark question. Next, nodal plane. Nodal plane means the plane which passes through a point around the nucleus where the probability of finding the electron is 0. Suppose if we pass plane through the atom to particular place, if we cannot find the electron, then that plane is called nodal plane. So what is the point? The plane which passes through a point around the nucleus where the probability of finding the electron is 0, that is called nodal plane. Number of nodal planes is equal to azimuthal quantum number, that means L value. Number of nodal planes is equal to L value. Next, here some orbitals are there, and some for that orbitals some nodal planes also given, which we will discuss. See, for s orbital, nodal planes 0. Why? Number of nodal planes is value how much? L. So that for s orbitals, nodal planes is 0, because L value is 0 for s orbital. In case of px, all p orbitals L value is 1. So for all p orbitals, number of nodal planes also 1. In case of px, that one nodal plane is there. That nodal plane is what? Yz. Because in case of px, electron density is present on x-axis. So we cannot find electrons in y and z axis. So if you pass plane through y-axis and z-axis, we cannot find electrons. So that yz will be nodal plane for px. In case of py, electron density present on y-axis, so that we cannot find electrons in x and z-axis. So that if you pass plane through x and z-axis, then you cannot find electrons. So that xz will be nodal plane for py. For pz orbital, xy will be nodal plane. In case of dxy, for all d orbitals, L value is 2, so that nodal plane is also 2. So for dxy, that means what is the meaning of dxy orbital discussed here? What is the meaning in case of dxy, dyz, dx? This in case of dxy, the electron density is present. Between the x and y axis. In this case, between y and z. In this case, between z and x. So in this case, what are the nodal planes? Two nodal planes. What are they? Xz and yz. That means if you pass plane through xz axis and yz axis, you cannot find electrons, because in electron density is present between x and y, so that those electrons cannot be found in xz and yz. So that these two will be nodal planes. Those are how many? 2. For dyz, 2. They are what? Xy and xz. For dzx, 2. They are what? Yz and xy. For dx square y square, also 2. They are what? Yz and xz. This is dz square. This is exceptional case. You remember this point. For dz square orbital, the nodal plane is 0. This is exceptional case. For dz square orbital there is no nodal plane. You just remember that point. There is no reason behind that one. You just remember that point. Next,